Okay, I think we can start. So, yeah, so good morning, everyone. So my name is Wang. I'm from Meta AI Assistant team. Also, I'm the co-project leader of OCP OpenRMC DM project. So today I will present an update on the OCP Rack Manager with John. So a quick agenda, two parts. So I will cover the first part, introduce the update on the OpenRMC non-spine interface specification. So the second part, John will talk about the detailed implementation for device manager. Okay, so a quick recap about the OpenRMC project. So we released the OpenRMC spec version v1.0 before last Go Summit. So so we have the hierarchy texture on the left-hand side. So the Rack Manager is sitting in between orchestration layer and the southbound management platform. So as for OpenRMC project is mainly focused on the northbound interface. As we know, the northbound interface capability also imply a southbound interface requirement. So after v1.0 release, we received lots of community feedback. So we consolidate and put some new change to the 1.1 spec. So there are three major areas. So we have made it to this new change. The first one is so we want not only be able to update the Rack Manager firmware, and we should also able to update all the node level firmware stack. The second category is we would like to enable group operations in case of to meet the challenge of the rack flexibility. So you might have lots of different type of nodes in the rack, and you have different vendor, and you are separate device rack nodes for different application, and you want to run different policy and group operation different groups. Okay, the third one is a major one. So we have our concern regarding the security from rack perspective between Rack Manager and the underlying the management node. So this is three areas. So we added to the v1.1 on top of the feature of the 1.0. So we're gonna talk about it a little bit later. So for the security portion for 1.1 is mainly regarding a security model from a software perspective. For the hardware security perspective, so maybe start from v1.2 to start with BMC security from Rack Manager perspective, and also some future other security perspective 1.x. So we will also have some future 2.0 open discussion, which gonna cover some, as we know from the keynote, so we have lots of new challenge for all the AI system, new requirement for the future data center. As long as we push all the power and the SDIS rate going high, we have AALC type of immersion cooling introduced. We have lots of photonics introduced in the data center in the rack. So we also extend did the in-chassis buses, I/O bus to even broader areas. How can we leverage very proactive, or even we call a very progressively telemetry data collection, and how to very intelligent use of this telemetry data. Also, we might have our involvement of the backend fabric. All this puts a lot of challenges. So this will, but this is not the focus of today's talk. So yeah, so on the top of the slide, there's a two link for the OpenRMC usage guide on the wiki, and also the OCP profile on the GitHub. So go back to the 1.1 three areas of change. So the first one is manage node firmware update. So the most common use case is like for for this is BIOS BM change. So you can we can update very specific node for very specific firmware you want to pick. Also, you can do a bunch of nodes of interest. So you can specify which selection of the nodes. So for the second one, the group operation. So the group operation actually is leveraging the Redfish aggregation service. So with this aggregation, we can divide and create a different group. This can be a persistent group or can be a temporary group. Also, if you want reset, make change to a group, you can definitely reset both the persistent and the temporary group. And once we have the group, so we can perform our different policy and different selection of the operation. For example, like a firmware update or set boot orders. So on the right-hand side is a quick example about setting the boot order for a persistent group of nodes to their default boot order. So very efficient. So I think the third area is address the security part. So the high-level brief problem statement initially for this is, number one, how can you ensure that Rack Manager is a correct one as opposed to one and to be authorized to manage underlying nodes? The second one, vice versa. So how can we ensure the newly plugged in nodes or even existing nodes are validly authorized to be managed? So how to address this problem statement? So we work with security projects. So the central idea of the implementation is to define a security model. This security model is leveraging the authentication, which require every entity in the rack, no matter it's a managed node or a rack manager, should have a certificate. Also, we need a workflow to ensure that all the node manager and the rack manager will obtain and update the certificate in a proper way. So regarding the authorization between Rack Manager and a managed node, the central idea and the requirement for this is so we do need each node and each Rack Manager gonna have a certificate. In meanwhile, so when we initialize the management node and the Rack Manager, we need to have a token place with signature on both management node and rack node. So in the end, so for Rack Manager, it will place a manifest which will hold a list of the management node certification plus the latest token for this node. So I'm not going to talk about very details about how we generate the certification, how the details about workflow. You can refer to the usage guide, session 6 with very details. So I think I will pass to John for device manager. Thank you.
Profiles, APIs, useful, but very academic if you don't have an implementation. With the BMC, the Redfish API for the BMC, we now have an implementation. It's called OpenBMC. It's been in existence for several years now, and everyone uses it. That's why one of the drivers of the Redfish interface for node management is that you can go out and get a conformant implementation and drop it in your BMC and run it. As a matter of fact, the Redfish forum works very intimately with OpenBMC, so they can submit issues. It's all dealt with in the public, and then finally we submitted an internal issue so we can go fix it. The background of OpenBMC was when Intel decided they wanted to add a Redfish interface and contribute it to the community. It went out and looked at the industry, and there were 6 repositories of OpenBMC owned by all big companies. And it took 6 months and a lot of negotiation to get them to agree on one, which was sent into the Linux Foundation, and that was the governance that we used. And only at that point did DMTF go in and say, okay, it's safe for us to add to this repository. At that time, the CTO of OCP came to me and said, John, it took 6 months to do this. Well, I believe the next management issue is going to be at the Rack Manager. And I do not want that to occur. I do not want the industry to bifurcate and have to be brought back together. So I want you to go create a repository for rack management. And that was my initial AR to get this thing done. We started by having 2 sections to OpenRMC. One was to define the interface, second to define the implementation. We spent a lot of time defining the interface, and only recently have we, in the last 2 years, have we figured out how to actually do the implementation. It started with a contribution by EdgeCore Networks. They contributed the device manager system. It composed of a device manager, which is in the red box. It also composed of a Redfish agent that ran on top of the operating system, namely Open Network Linux. And with that, what that allowed was that allowed networking systems, which basically have their own operating system, never had a BMC in their lives, actually support the Redfish baseline interface, because you could just download the Redfish agent, drop it on top of the Open Network Linux, and they will now conform it. So that existed for quite a while. And then, so we started, I started looking at the device manager and looking at the northbound interface. Northbound interface was a command line interface. It had a protobuf interface for streaming data out. And I said, that thing needs a Redfish interface. And that Redfish interface should be the one that we're defining in OpenRMC. Okay, so that's the first task that needed to be done. Second, the Redfish service that ran as an agent was problematic. It didn't quite compile, had to be fixed. It didn't quite conform to the baseline profile. So early last year, Celestica came in and said, John, we fixed it. We fixed the software agent. We are shipping a switch. We needed to conform to the baseline profile. So we took this thing called the PSME. We fixed it up. It now supports the entire baseline. And we are going to contribute to Celestica as a OCP product into the marketplace with this software load. And all this comes back to what OCP stands for, which is open, right? You need open hardware. We discovered very early on that open hardware is great, except you have all these microcontrollers, and no one knew how to build a firmware. Firmware came as a package image, right, that you just dropped in, and you couldn't modify it in any way. So the only way OCP was going to continue was that we open up all the firmware, which is why OpenBMC was championed. And then there's OSF, which is the Open System Firmware Project, which is OCP needs to get into open hardware, open firmware, and if open software came around, we'll take that too. So with the PSME, we now have capability to do that. So now we are at a point where we have agents that run in BMC. We have a service that runs on top of the OS in case you don't have a BMC. And the only thing is this rack management thing. So why do you want to do rack management? You want to do rack management because you want a higher level of abstraction. So you have Redfish because it gives you an abstraction, go talk to the node, right? You say power recycle, right? Reset, right? It doesn't know how it's done, right? It just says every system you have, you activate this Redfish action command, and it will go reset itself. The same thing happens to when you get into a rack. You don't want to do a firmware update on every node. You want to firmware update everything on the rack. or you want firmware update some small subsystem or group of systems in a rack. So that's what Redfish for OpenRMC does. It says, I want to pick out these set of nodes in my rack. I want to do the update. Right? I don't want to go look at each one of them. I don't want to find them. You're the rack manager. You know all this stuff. You guys should go do it. Okay? So that was the genesis of rack management. So when we get to power capping, so you can power cap at a node. Right? That's power. It's not as useful as power capping at the rack. So when you hit power capping on OpenRMC, you set the power cap for the rack, because that rack is plugged into a fuse. You don't want that fuse to trigger, so you cap that rack, right? And if it gets close to the rack, then you either have an automated action for it to occur, or you set a policy for it to go notify somebody. And if it's somewhere up above, then the data center manager can decide whether it needs to revector power, whether you're important, you have to revector power, or you're unimportant, that should just shut you down and use your power for someone else. Okay? How close am I? 3 minutes, great. How do you page down this puppy? Okay. So what we do, I'll go through this quickly, is there was another group called ODIM, which I have the link there, and they're doing distributed manageability, also Redfish, written totally in Golang. Device manager was written in Golang. So I said, guess what? We're going to go over there. We're going to ask them if we can take this stuff and layer it on top of device manager. I went. They said yes. I said, how do you want me to do the attribution? They said, whatever you want to do is what we're happy with is all open source. So that's what we've done over the last year, is actually drop ODIM on top of that. So ODIM came with accounts, events, task sessions, session service. It came with an aggregation service. It came with an upgrade service. So it was a fairly deep integration, and we just moved device manager into one of the things you could provide. So, so you could actually do connection methods that use IPMI, which we did not do. So that was completed middle of last year, and we're in the process of finishing up the firmware update and aggregation service. So the status of the OpenRMC project in Device Manager is currently community we're ramping up to 1.0. Hans said that version 1.1 just came out with aggregation service from update. We're going to meet that almost soon right after that. Most of the actions are implemented. What we found was we didn't have a cascading way to actually set a property because that was easy. So that's being implemented. We've aligned the specification to be tested with the interop validator, so that we should be able to now take this, the profile, run it on validator, run it against OpenRMC implementation. So all this work is being done in the repository. So there's a repository for the device manager, and there's a repository for the PSME, which is a software agent. Down, down, down. Okay, call to action. So 1.2 specification, 2.0, we've called it various things. So as far as I'm concerned, I fulfill what the OCP CTO told me to do, which is we now have an implementation for a rack. Hopefully, this may or may not prevent divergence. I'm done. So I and Han and Marcet, who is on the cover slide, who is in Poland, who could not get here, have all been kind of working on this, and I basically said, because I'm steering committee rep to the hardware management, is that this group should not exist if we don't get community input, right? We've done everything we needed to get this in place, and if we can't do PowerShelf and plug this into this rack manager and get people interested in using it, then well, this group may not need to last beyond this. So as far as I'm concerned, 1.2 cannot come from us. it's got to come from the community. If you need additional functions, we need to hear from you, because it's not going to be a bunch of engineers in a room trying to figure this out without use cases and uses people who actually want to utilize this stuff. Okay. So there was one RMD project which was announced, I think, a year ago, where they were actually going to develop a rack manager. So that never happened. So we thought we were going to land on there, and that would have been great. That came and went. So right now we have a device manager. It will build, install. It will test component implementations. And so we have a monthly meeting. Come join, come tell us what you want, what you need, and we can attempt to implement it. But pending that, then I've told Han to slow it down, that we're not going to go add additional resources to add a bunch of functionality that we're not going to, that the industry doesn't need or the community isn't going to use.